Good day, class. As you can see, we are going to learn mathematics. And the topic is factors. And that factor, we're also going to learn HCF. At the end of this teaching, you'll be able to know what's the meaning of HCF and how to solve it. First of all, we want to know what a factor is. We said that a factor of a number can divide that number without a remainder. Let's quickly look at the example. The example says find all the factors of 12. First of all, for us to find the factors of 12, I always prefer to start with the smallest number, which is 1. We say 1 times 12 is 12. The next number after 1 that can multiply to get 12 is 2. So if we now say, what will I multiply by 2 to get 12? The answer is going to be 2 times what is 12, which is what? 2 times 6. Then the next number after 2 is what? Is 3. Then in this case, it's not supposed to be serial. If at all maybe you try 3, it doesn't go, you go to 4. That's how it's supposed to be. But in this case, 3 can go. Because when we say 3 times a number will give us 12. So 3 times that number, which is 4. We said 3 times 4 is 12. Let's go from the beginning. 1 times 12 is what? Is 12. Let me write it out. 2 times 6 is what? 12. And 3 times 4 is 12. The next number, since 4 is already here, we don't need to now say 4 times 3 again, because it's going to be like a repetition. So these are all the factors of 12. So I always use arrow to indicate the direction, because we are going to list all the factors in ascending order. So it now says, therefore, factors of 12 equals 1, list them from the smallest to the biggest, 2, 3, 4, 6, and 12. So these are all the factors of 12. Any of these numbers can divide 12 without a remainder. Then that leads us to the next subtopic, which is called the HCF. What is the meaning of HCF? HCF means highest common factor. Highest common factor. But before we need to we find what the HCF, we have already found what factor is, which we have done here in the example. So the next thing we're going to look at is the CF, which is the common factor. How do we know the common factor? We say that 2 or more numbers may have some of their factors to be similar. Then the largest among them is called what? The HCF. We're going to see it in this example. The example says find the HCF of 12, 18, and 24. There are 2 methods to use, and we're going to use the long method first. First of all, we want to find the factor. The factor is just the same thing that we did here. The factors of 12, we have already discovered the factors of 12. We're going to list them out. Factors of 12 are 1, 2, 3, 4, 6, and 12. You use this method as I did to find factors of 18. Use the same method here to find factors of 18. If you do that, we can do it somewhere here. Let me quickly do it here. Factors of 18. 18 is 1 times 18. 2 times what is 18? 2 times 9. 3 times what is 18? 3 times 3, 9. 3 times 4, 12. 3 times 5, 50. 3 times 6, 18. Okay? So 4 cannot give us 18. So these are all the factors of 18. So we list them out here. 1, 2, 3, 6, 9, and 18. We do the same thing with the factors of 24. Just the same way we did here. Find factors of 24. 1 times 24. 2 times 12. 3 times 8. 4 times 6. So you can see that all of them are factors of 24. You list them out. 1, 2, 3, 4, 6, 8, 12, and 24. So these are all their factors. The next thing we're going to find after finding this factor is to look for the common factors. Common means those numbers that are similar, that are the same. So you can see that 1 are common here. So you now write common factors equals to 1. Which other numbers are the same? 2. You write them out. 3 are the same, okay? 4 are not the same because there is no 4 here. You skip that one. Go to the next one, which is what? 6. Then let's see whether there is any other one. Is there any other one that is 6 that are the same? There is no other one. So these are all the common factors. Now you go to the next one, which is the final, which is the highest common factor. Among all these common factors, which one is the highest or the biggest number? The biggest number is 6. So therefore means that 6 is the highest common factor. If you use this long method and this short method, you're going to arrive at the same answer. But I always advise that when the numbers are small numbers, you use this method. But if the numbers are big, because when you get to the upper class, you see that the numbers will be increasing. It's not advisable to use long method. You therefore use the short method. Let's quickly look at the short method. You write the 12, you write 18, and you write 24. You now ask yourself, which number can divide any of them without a remainder? You can easily see that 2 can divide them. 12 divided by 2 gives us 6. 8 divided by 2 gives us what? 9. 24 divided by 2 gives us what? 12. So you can see that we have finished the first stage. The second stage, you now ask yourself again, which factor can divide all these numbers without a remainder? You can see that the only factor that can divide all of them is 3. So I write down 3. 6 divided by 3 gives me 2. 9 divided by 3 gives me 3. And 12 divided by 3 gives me 4. In this case, you see that there is no number that can divide all of them. So that's n. That is the end of it because there is no other number that can divide this. You now conclude, therefore, HCF equals to, you write all these. These numbers that are represented by the left hand side are the factors. So you write them out. 2 times 3, which is what? 6. You can see that this one and this one are the same. But this one is easier and it's faster than this. Is that clear? So having known this, let's quickly look at what are prime factors. We say that prime factors are numbers with only 2 factors, themselves and 1. The condition is that there must be 2 factors, themselves and 1. Any number that has more than 2 factors or less than 2 factors is not a prime number. So from the list of numbers that we have from 0 to infinity, these are some of the prime numbers. We have 2. 1 is not prime. Reason is that 1 is only one factor. It does not have another factor. That's why we don't include 1 as a prime number. So prime numbers are listed below. We have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 34, and 41. There are so many of them, the other ones. So you can see that these numbers is only themselves and 1 that can divide them. Let's quickly look at this one. Example is given here. We have express 32 as a product of the prime factors. How do we now express this? What you do is you write the 32. Now you ask yourself, which factor can divide 32 without a remainder? So you now see that 2, I always advise start with the smallest number. It's not good to start with a bigger number. For example, some people used to start with 4. We know that 4 can still divide. But you see that any number that 4 can divide, 2 can as well divide that number. So always start with the smallest number. You now say 32 divided by 2 is going to give us 16. You write down another factor that can divide 16 again. 16 divided by 2 will give us what? 8. You now ask which number can divide 8 without a remainder. 2 can as well go there. So you now say 8 divided by 2 we have what? 4. 4 divided by 2 gives us what? 2. And 2 divided by 2 gives us what? 1. So these are these factors are the prime factors of this. So you now therefore list all the numbers. You have 2, 2, 2, 2, excuse me. So if you multiply it, you're going to get 32, or you write it in an index form. The index form is 2 raised to power the number of 10, which is 1, 2, 3, 4, 5. So this is written in index form. You you write it like this, you are correct. If you write it like this, you are correct. So this is the way you are finding prime factors. I hope that you actually understood the explanation in the video. If there is any part that you are missing out, you can easily go back to the previous option I gave to you and try to look at them again, and by so doing you understand every aspect.